They made this so annoying. Took off 2 sheet metal screws here, and I thought the side would just come off, but no. This is welded to this, which is connected to the chassis by 1 screw down in there, which you really can't get to unless you take the CRT out. Grr. Well, I was saying, I think the first thing I would do is start maybe recapping and checking more components. Well, I think actually the first thing I really want to do is clean this more. So, I didn't want to take the picture tube out this early in the game, but I really do want to get down in here and clean it out. Because even if everything's fine, tends to be a lot of dust and dirt accumulates down in there, and you can get arcing and corona. So, well, the base comes off easily enough. There's a dual ion trap, which I think it's just on there by, just clips on. I'll take some reference photos. It'll help me putting it back on. Loosen up this band, and then it should just pop right out the front. It's already loose enough in there. And yeah, just yank that guy off. This thing hasn't been powered up in many years. There's no way there's a charge on anything, but it doesn't hurt to be safe. Yeah, there's no charge. Alright, that was fairly easy to get out. Yoke looks a little nasty, but I think that's just from the old goo they used while making it. So undid the band and just pulled it out the front. This actual felt or whatever this material is actually seems to be in fine condition, so nothing to worry about there. I got my 1 screw out, so now we can peer inside this. And it's hard to see, but it sure looks like flybacks I've seen many times before. Such from this vintage. Some surface corrosion. I did actually clean that off once. It's not that hard to take these apart, but I don't really think it warrants it. Take off these screws, pop off the end caps, and this is made from several pieces. So there's 1 piece here, 1 piece here, and then a center core. You can take it all apart, throw it in some evapor rust, put it all back together, but I think that's really overkill. Ooh, that looks a little nasty down in there. I think it's just many years of dust being attracted by static electricity. Just gently brush that out. Compress there. It's looking better already. I've got the power transformer top primered up, ready for some black paint. Be nice to remove the whole thing and really do it up nice, but boy, I don't want to take that out. Redo all that wiring. Plus, it's not that bad on the bottom. But one thing I am thinking about taking out is this, which is the high voltage subassembly. Because it appears to be on a chassis, a little sub-chassis that'll come out. Take out these 2 screws, I think there are a couple on the other side. Disconnect a few wires, I can take this whole thing out and really work on it in detail, because I noticed on top this is pretty corroded, and it's really hard to get down in here and clean all that out. And it does appear that this is bad. Just no surprise to me. They always seem to be open. Now, it's not measuring open, it's measuring about 7,500 ohms, but it's supposed to be about 3,500 ohms, and it's still connected in the circuit, so I think that resistance is coming from elsewhere in the setup. But if I disconnect this wire, it's going to measure open. Anyways, yeah, so I think if I take these 2 out, and these 2 out, and disconnect a few wires, this will just pop right out, which would not only allow me to work on this, a lot better, but to open up this area for working on other parts of the set too. It was actually fairly easy to get this high voltage subassembly out of the chassis. Just had to disconnect a few wires, take off those screws, and here it is. Now I'm in the process of taking this stuff off. Just a few wires connected to the flyback, and the socket here, as this socket's rather corroded, as is this. I tried putting a little navel jelly on it, and it's had some effect, but I really want to get this whole thing apart and get it all cleaned out and checked out. So I figured I might as well just go for it. I think what's a little tricky is a screw holding in that doorknob cap. I guess I can get it. So it's kind of right down in between some components, but there's just enough room. That screwdriver is too small. Give this guy a try. There we go. Something I always try to do once I get a screw, a nut, washer off, whatever, is take it and attach it right back where it goes so it doesn't go astray. Or even when I used to save them all, like put them in like an empty plastic container. That's great, so I've got them, but I got to remember where the heck did they go. So yeah, reference photos can help, but sometimes when you got a pile of screws that all look rather similar, it can be hard to tell what goes where. So I can do this back in here. And everything should be disconnected now, so if I just undo a few screws going to fly back down, all this stuff should come right out. And once I get this out, I will also test the flyback. Looks okay from most angles, but I discovered that one side things look a little melted or charred. Not charred, but like melted. Probably just age and heat. Oh, and I was puzzled earlier by the presence of two linearity controls. Well, that one of them is a potentiometer mounted on the front of the chassis, and the other one is this coil right here, and then this is width, which is a more conventional setup. I've also printed out the SAMs, and if you look at that, here is the linearity coil adjustment, and the width, which is a very common design. But it also has a linearity potentiometer in here. So imagine it'd be a little touchy to adjust all this stuff. And now let's see. It's a little hard to get this screw because this one's in the way, so just loosen this up. Okay, so this cable out of the way. It's actually the charging cable for my video camera. I'm getting tangled up there. Alright, now all this should come out. Yes. That's how the top should look. Nice and shiny and clean, but get corroded. So there's what I was talking about. Actually, it looks even worse than I realized now that I can really get down in there and see. Ooh. Is that a wire? Could that be a bit of wire? Or is that a thread? I think that might just be a piece of thread. I don't think it's a wire. Some of this is just accumulated dust. But boy, that's really cracked. It's a bit different coating than I'm used to seeing. I suspect it's wax. I can find that out pretty easily here. Yep, melts alright. It's wax. So, perhaps I could use a heat gun and just kind of reflow this wax. And I do have some microcrystalline, high temperature, high quality wax. But, I got a Faventi radioform a while ago. There was the discussion going around was, what can you use to recoat these? So you can use silicone, as I've used in the past. But I also do have this wax, which is very pure, high temperature, and has a decent high voltage breakdown. I could try putting on here. So I really don't want to try breaking all of this off and recoating it. But it's definitely separated in a lot of areas. So I think I'll just get the heat gun and just try like touching it right here. Heating it up a little bit and see if it'll kind of like flow back, or I can kind of mush it back down on there. But before I get ahead of myself, I want to test this before I waste any effort on that. And now I can, no problem getting in here, clean this off, get rid of any rust, and really get a town on it. And replace all this, and I imagine things are going to look quite a bit neater and smaller. Once I get the new parts in there, the new caps will be much smaller. I'm going to test flyback with my ICO 944. I've yet to find a bad flyback actually, but I figured it's the first time for anything. So the way this works is, first I'm going to check for continuity, and to do that, put on continuity. You can adjust this with nothing connected for calibration continuity. We put the probes together. Bottom scale continuity, it should swing over into the green. Alright, so let's see how we do here. So first I'm just going to go off the main two terminals. This would be your high voltage winding. Get on there. Good. Now you want to go through all the primary windings, all the taps. So let's see. So it goes off this page here, but I just checked between terminals 2 and 3, so I should also go between 1 and 2. 2 being, or 2 and 3. So 2 or 3 is these plate caps, and 1 will be labeled on here somewhere. This is 1. Very good. And we should have counted between 4, 5, and 6. Which, let's see, that's 5, that's 4. It's not labeled on here, but well, with no numbers, got to be 6, I figure. So good, good, cool. Now let's check for shorts, and to do that we go to shorts. This is iron core, so I switch the calibration over to iron core, and this one you only go between these leads. You can get a little bit of a jolt sometimes, so I want to just handle one of these at a time. And that's good. It should deviate a little bit, typically, but not go way off. Cool. I'll try simulating a short by going between one of these and position one. Should I stick this here? So there. So if this was, so imagine this was a short. This dipped into the bad. So looks to me like we have got a good flyback. Same thing over here. And now notice I didn't have a tube. You need to remove the rectifier tube from that socket, because that can throw it off too. And they say one check to see that everything's alright is when you put a tube in there, the needle should dip down possibly into the bad region. So I'm going to dig up a 1B3 rectifier and pop it in there. Here we go. Nice Filco tube. Dipped down, but didn't go into the bad. But the fact that the needle deflects at all, that's a good sign. Because this is sensitive enough, I can detect that load on the coil. Alright, so that is all excellent. And now I'm going to try reflowing that wax. I had some success with the wax. Between my heat gun and a small flat-bladed screwdriver, I kind of mushed it into shape. This is sticky stuff when it melts. So it's not quite like beeswax. If I could somehow magically heat this from the inside out, I think it would work a lot better. But blasting in heat from the outside in, the outer surface immediately starts to melt and flow around. So what it is, I kept the heat very low and actually used a screwdriver to kind of push it into shape. Not perfect, but certainly a lot better than it was. Now, since I've gone this far, and I've done it before, and I know it's not that difficult, and I thought you guys might find it interesting, I am going to take this apart and remove that corrosion, and plus I can go over that wax a bit better without this stuff in the way. So first off, I just took off the strap, just simply held in with 2 screws, and then these end caps just pop off. So they are pressed sheet metal, and that holds the cores together, so you gotta get that off. Isn't too hard to do if you apply pressure at the right point. It'll start coming loose. You always want to be careful not to damage anything. Okay. So you can see it's actually rounded on the ends there. Just 3 pieces of this side, and then a cylinder that goes down the middle and locks it together. Oh, yeah. Got lucky here, it's actually loosened up enough. It just comes right apart. Other side stuck a little bit. And it can be a little tricky to get this off and around these lugs. A little bit careful maneuvering. And there's one side. Oh. Well, I guess I gotta get the cylinder out. I can't slide this one out on this side because this board extends out. The centerpiece can get a bit stuck over time. I might have to use a little bit of adhesive on or something too. When I heated it to melt the wax, I might have flowed a little bit down into there. Oh, all right. And finally, actually, I did use some sort of adhesive. It's just some insulating wafers they use. See, there's the winding for the rectifier tube. And there we go. All apart. So now we can remove the rust, corrosion. Oh, there's some on the inside too. And just simply put it back together opposite way it came apart. And the core doesn't really have much rust on it, so I think I'll just leave that aside. Let it sit for a few hours. Now I can really get in here and reflow that wax or add more to it. Here's that block of wax I had mentioned. So I'm going to carve off a bit of this and position it in a ring around here and then heat it up and to melt it into this main body. So the outside rim is okay, but I think I can fill it in better around the sides. Don't know how compatible these two are, of course, but I'm hoping it'll work out alright. If not, hey, I can always take this thing apart again and recoat it with something else. So I'm just using a razor blade to nip away some of this wax. And yes, I've seen Shango66's video where he recoated a flyback in a vat of beeswax with vacuum setup, which is cool. I'd do that if I could. Although really these types of flybacks, they didn't coat the whole thing. It's just this like a tire around the outside. So I'm just trying to replicate that. Alright, not exactly a thing of beauty, but it'll do. And got the corrosion off the core, so time to put it all back together. Once I got the flyback back together and reinstalled, I just got to it and cleaned up everything and did a recap and replaced the resistors. So all of these guys are actually 2-watt resistors, small as they may look. Those are some Vichy 2-watt metal film resistors, and here's what the originals will look like. And believe it or not, this was a 4.7K resistor according to the service info. Measures about 2K now. That was in right there, and you can see the wire underneath where it went is a bit charred. So for sure that had to get replaced. And I generally like to replace everything in the horizontal circuitry with high quality components, because that's a very common area of trouble. Got a lot of power going through this. Oh, and I popped in the tubes that were missing. So there's a 6BG6 and one B3 rectifier. Got it all cleaned up, that high voltage area, cleaned up these ceramic standoffs. And it's all ready to be reinstalled. Also, I'll replace this guy here. This has nothing to do with the circuitry in this area, which kind of had me puzzled. I think they just use some convenient tie points, and these then 2 wires attach and go off elsewhere. Same with this guy. So that's why there's actually nothing connected to these. I connect the wires that, as I say, go elsewhere. So this one actually measured okay, 250 ohm, but I think this might have been a replacement. It says 5922, which could very well be a date code. And I noticed some other evidence that a little bit of work was done on this set. So we had that fried resistor. I think this was a replacement. Both these tubes were missing, so there may very well have been trouble in this area. And also this mica cap was clipped out, and it was just tacked back in temporarily. It should connect to this point right here. That's a fairly important capacitor. That is part of the horizontal drive circuitry. So there's a 0.1 microfarad cap to couple the signal to the grid of the horizontal output tube, and this here's that 680 picofarad mica cap that was clipped out. And they hooked up to the linearity control, and I imagine if you clip that out, it's going to allow more signal to get through, but also probably the wave shape is a bit wrong too, because you don't have this resistor. I go with this feedback here, so I will double check that capacitor. I'm kind of inclined to just replace it regardless if I got a 680 picofarad mica cap on hand.